So now after knowing all the properties, the meaning of properties, the state, the process which the system undergoes, we will again try to understand first law of thermodynamics. First law. So first law is the law which you know already in your earlier classes in 9th and 10th. That is the law of conservation of energy. Law of conservation of energy. What is this law of conservation of energy? Energy can neither be created nor destroyed. It can only be transformed from one form to other. In simple words, you cannot create energy, you cannot destroy energy. You can only transfer it from one form to other. Like kinetic energy can be transformed to potential energy will convert to kinetic energy, and all those things. Now, but how do you relate this first law in thermodynamics? So as I wrote before, that the first law is the heat transfer is to the system is equal to work done by the system plus change in internal energy of the system. So still we have few definitions, that is the heat transfer and the work transfer. So first let's see the heat transfer. What is heat transfer? Heat transfer is energy transfer from high temperature body to low temperature body. If there is a body having some temperature like 70 degrees centigrade, if there is another body having temperature, or if you can see if there is a surrounding having temperature of 30 degrees centigrade, so basically the heat will transfer from 70 degree body to 30 degree body in this direction. This will happen spontaneously, and that transfer of energy from high temperature to low temperature, this transfer is only called as heat transfer. And what will happen by this heat transfer? After some time, if you observe this 70 degree will become some in between some temperature like 45 degree or something, and this also surrounding will also become 45 degree. If there is a limited surrounding, then both the bodies will attain a common temperature. So this will happen, this heat transfer happens until both the bodies attain the same temperature. This is heat transfer. Now let's study work transfer. Work transfer. So as in the earlier classes, we used to study what is the work. So work was simply defined as work is nothing but force into displacement. That was work. Similarly here also, work transfer is wherever there is a displacement like expansion or compression. So expansion or compression, that is the work transfer. So whenever there is when there is a change in volume, so that is a work transfer. Okay. So expansion or compression is work transfer. Compression of the system. If the system is expanding, for example, if there is a gas and it expands like this, and it increases its boundaries and it expands like this and volume increases, so the work is done by the gas. The work is done by the gas or by the system. This is called work is done by the system. System is doing work on surrounding, therefore it's expanding. And if you are compressing the system, for example, there is a gas here, and you are applying the pressure over the system like this, and you are trying to compress the system, and the gas occupies a still lesser volume and volume is decreasing, so you are doing work on the system. So this is called as work done on the system. Work done on the system. So there are two types of work. One is work done by the system and another is work done on the system. And when you put these terms in first law, then work done by the system is taken as positive. Work done by the system is taken as positive, and work done on the system is taken as negative. This you have to remember, that work done by the system is positive, work done on the system is negative. This is very important. Likewise, heat given to the system is positive and heat given by the system to the surrounding is negative. Heat given to the system is taken as positive, and heat given by the system to the surrounding, that means heat is released by the system to the surrounding, is negative. So this also is very important sign convention. And the second thing is, the last thing is the internal energy. Internal energy. What is internal energy? Internal energy. Now as you can see, this word energy, everybody knows, Energy is the capacity to do work. But what is internal? Internal means energy contained inside the body. How do a body can contain energy? For example, a gas. So we can first write this. Energy contained by a body is internal energy. Contained by a body is internal energy. Now how a body can have energy? For example, you take an example of gas. A gas has molecules. So many molecules. These molecules. Now these molecules will have some intermolecular force of attraction. They may be attracting each other. Because of this attraction, these gas molecules will have some potential energy. Potential energy. And these gas molecules may be vibrating. And if they are vibrating, then they will have some vibrational energy. Vibrational energy. Or this vibration is nothing but a velocity, so they may have some kinetic energy. They may have some kinetic energy. So likewise, because of the interaction of these molecules with each other, there are so many energies associated with these gas molecules, and if you add up all these energies of all the molecules, then that makes up the internal energy of the entire system. So if a gas is there, it is having so many molecules, those molecules are attracting each other, those molecules are vibrating in their place and from one place to other, and because of this, total energy contained by the gas molecule is the internal energy of the gas molecule. So that is internal energy. But what is the difference between heat, work and internal energy? What is the difference between heat, work and internal energy? So when you saw the heat was nothing but the transfer of energy from high temperature to low temperature. High temperature body and there is a low temperature body, and when these bodies are coming in contact with each other, low temperature, and when these bodies are coming in contact with each other, heat was getting transferred. Work was nothing but expansion or compression. Work was nothing but expansion or compression of the system. So when you are compressing the system or the system is expanding, work was done. And internal energy is contained by the system because of its molecules, which are so many and having some molecular force of attraction and having some vibrational energy and kinetic energy. So what is the difference between the three? The main difference is that the heat and work, this come into picture only when there is a transfer. For example, this is high temperature to low temperature, there is a transfer. So basically this is a transit. The system is going from one state to other. The system is going from one state to other. The system will lose the heat and will reduce its temperature. So it is going from one state to other. Work transfer. System is expanding. So basically it is changing its properties. So system is going from one state to other, and that time only work transfer will happen. But internal energy is contained by the system. For that no need to do any process. It is already contained in a system. So heat and work are energy in transit. They are not contained by the system. They are not contained by the system. Nobody can contain the heat and work. You cannot say, I am having 10 joules of heat, I am having 15 joules of heat, I am having 30 joules of work. You cannot say. You can say that I transferred 30 joules of heat from myself to the surrounding. I got 30 joules of heat from surrounding to myself. So this is basically transit. Like you give money and you take money. That is what is heat and work. And what is internal energy? Internal energy, you can say, I am having 30 joules of internal energy. Yes, it is there inside your wallet. You are having 30 rupees money in your wallet. So that is called the internal energy. It is the energy contained by the system, and these are the energies in the transit. These are only energy in transactions. They are not contained, but this is contained by the system. That is the main difference. So these are all the brief introduction of heat, work and internal energy. And I think now we are in a good position to define our first law, which is the law of conservation of energy, which says that the heat transfer, when you give the heat to the system, heat given to the system is equal to the work done by the system plus change in internal energy of the system. A very good example of this first law is to understand the first law is what we will do is we will take a system, we will take a cylinder and we will take a piston and we will have some gas inside this system, and what we will do is we will try to, this gas is having some pressure P1, volume V1 and temperature T1, and what we will do is we will try to transfer the heat to the gas. We will give the heat to the gas. So what will happen? We are giving heat to this gas. What will happen to the gas? If you give heat to the gas, gas will try to expand. Gas will try to expand and gas will move this piston up, and what will happen that this piston will move up like this and the gas will expand and volume of the gas will increase, and volume from V1 it will increase to V2, and V2 will be more than V1. Gas will expand, pressure will also change. There is certain pressure P1, now gas is expanding, pressure will change from P1 to P2. Temperature will also change because you are giving heat to the gas, you are giving energy to the gas, therefore temperature of the gas will also increase, temperature of gas will go from T1 to T2. Now by giving heat to the gas, you have done two things. Number one, when you gave heat to the gas did some work. What work? The work done from changing volume V1 to volume V2, the gas expanded, and that is the work done by the gas. So the gas did some work, and what else happened? The energy of the gas got increased. How the energy got increased? It was having temperature T1, and when you gave the heat, its temperature became T2, and temperature is a measure of internal energy. Temperature is the measure of internal energy. More is the temperature, more is the internal energy. So basically by giving heat, you are increasing the temperature, and if you are increasing the temperature, you are changing the internal energy of the gas. So you did two things. You gave heat to the gas did some work against surrounding, and the internal energy of the gas also got changed. So what has happened in this process? The total energy should remain conserved. You have given some heat, that heat got converted into two things. Number one, it got converted into some work, it got converted into some internal energy. So how do you define this entire process? You have given some heat to the gas, and this heat got converted into two things. Number one, that work was done by the gas, and second, the temperature of the gas got increased, because of which internal energy of the gas got increased. That's all. So heat you have given, so it's positive here. Work is done by the gas, therefore it is again positive, and internal energy has increased, therefore it is also positive in this situation. So this is the first law of thermodynamics, friends. I hope this video helped you to understand first law. And I hope that with this fundamental, we will try to solve some more problems on on first law. So this was all from my side. Thank you very much, and best of luck. Thank you.